Hang on. Check this out. Oh, this is cool. Today's Captain's Blog is made possible through the support of Crazy Joe. If you're interested in being a part of this and helping out and helping me make better videos, check out the links below in the description where you can get involved and be a part of this. Thank you. Hi there guys, welcome to today's Captain's Blog. We're here today for an equipment autopsy on a Biddle Instruments Megger. Now a Megger is a megometer, and these things, really, probably the reason that you're alive this long is because of one of these somewhere. This is used for testing insulation, breakdown resistance and voltage and stuff. And we're going to take it apart because, I'll show you here, let me pop these out. Because you see there's no screws on the back, so that means they're hidden. And that means they're down to little holes. But this, if you look at the end here, it's a hand crank megometer. And she got a case of the wobbles. So that's, yeah, that's no good. So we're gonna autopsy this because I can't trust it as, as the instrument. That, and it's really old. This is probably 80s vintage. I've had this for years. This has been in the autopsy pile for years, and I've just never gotten around to doing it. So I want to check it out. We're going to take it apart. We're going to learn about it. Because I think what's inside is a little hand crank generator, and that excites me. So let's see what's inside it. Now we're going to need, that's I think that's a straight blade. Wow, old. I didn't know it was like that old to have straight blade screws in it, but okay. And I expect this will be a relatively quick and simple autopsy, but it's just one I've been wanting to do forever because I am a huge fan of little hand crank generators. Like the old telephone ones, things like that. Oh, our weight's on the bottom. Okay, so knock those screws out. Let's see what secret she gives up. Okay, so inside we've just got nothing special. Push clips, not designed to ever come off. And hey, it lasted like 30 years. Oh, we've got gears. Okay. So there's our problem. Wow. I could fix this. I could absolutely fix this because we can see this has the weeble wobbles, and we can hear something rattling around in there, and it's very obvious that a screw belonged here and now is not there. So if we wanted to fix this, all we'd have to do is shake it, and that screw is going to fall out eventually. Allegedly, in theory, a loose screw should fall out. I can hear it in there. It might be stuck on the magnet or something. All right, carefully, and we'll set that aside. Those are our 4K screws. Take that out. And yeah, we're still going to have the two wires connecting it. But that should let all this move. Oh, there's a lot of little wires. Oh, we're missing a screw in the back too. Okay, so there's two screws rattling around in there. I got questions. All right. Well, then we're back to autopsy mode because there's two different screws rattling around in there. How do I I'd really like to decase the whole thing at once. But it's not making that easy. Okay, so here's you. That whole module. What's holding that? Oh, I think we have hidden screws. I think we have hidden screws under this little sticker here. Could be wrong, but I'm not. Look at that, hidden screws. I'm on to you guys. Oh, they're going to take a little effort to get out. My screwdriver is too big for this. But I happen to have, right here, a smaller screwdriver, one of my little Kleins. Let's take that out. Okay. And now, with the exception of the output terminals, I think all the major internal components will come free. Okay, cool. So now we're down to just the output terminals, and that's just a couple banana leads, and those we can just clip off. Okay, so our tools out the way. This is what we've got, and we found them. There you go. No, those are the ones. All right, so they're still in here. Because that's it. That's one. There should be two. But we found one. Where's the other one? Sitting on the table. That's it. That's the two screws. Because we have our 4K screws here. Okay. We have our two screws from the switch. Get up there. Get in your box. We've got our two screws from the lower bit, and then these extra two screws went here and here, and they attached here and here. There's a third screw. There's a screw, you can see there's a hole in the middle of that, so there's three screws that held that down. I only found two, so I gotta wonder, has somebody been in this before? The answer is probably yes, given its vintage. Somebody probably tried to fix it. So we got three wires coming off that transformer. Huh. And we've got a relatively simple circuit here. That's interesting. What are those? 0.22 M250. I don't think it's a resistor. It's got that capacitor. Oh, it's a capacitor, C2, C3. Totally a capacitor. You can see it says C2, C3. So those are caps. That's a cap. Those are diodes, which are kind of a cool red color. I've never seen diodes like that before. Huh. Simple little circuit. Let's cut it apart so we can get a look at each component here a little better. So here's our leads down to the meter. Three different leads to the meter. Okay, so now we have our circuit board, which lets us select from the two different modes, and one is that direction is ohms, that direction is mega ohms. Is it mega ohms or meg ohms? I've heard it pronounced both ways. I think it's mega ohms personally. That's what I'm going with. We can see we've got the number on the board here, Bravo 31624-070-4. Somebody smarter than me can probably look that up and give you a date of manufacture on it. And for all of you who want to reverse engineer your own megometer, you could absolutely make one of these boards at home. This is the level of the home hobbyist now, which is pretty cool. All right, so what else we got? We've got the meter, which is cool and scrapety. Let's pull that off of there just a touch. There we go. So on the meter, we've got one connection up here. We've got the other two connections down here that go to the two springs, which go to the two coils. I wonder if that's two different ranges? I don't know. It's a meter with dual windings. I've never seen one like that before. I wonder how that works. Hang on. Check this out. Oh, this is cool. All right, so there's one winding that goes all the way around, right? This winding here goes all the way around, but this winding only goes around one side of the thing, and when we're off to the end, this winding isn't engaging with any of the core. It's just out here in space. Now this is magnetized, very magnetized, and it has been since October of 1970 what? What year do you think that is? It's 1970 something. 2, maybe? Oh. Well, that tells us how old it is, 70s. If it's 1972, this thing's older than I am, and I'm old. And we have some little metally bits here that were attracted down to the magnet. I don't see anything else hanging out on it. That's so cool. All right, so that's our meter. And then this is the part that I was excited about. Everything else has been cool so far. Like the circuit board's like, eh, but this is the part I was genuinely excited about. Now this is a geared up like crazy. Look at that gear train. Wow. This is a little generator. Now, experience and painful lessons have taught me not to just grab this thing and start cranking, because that hurts. Like if you just grab this, you're gonna make like geared up like that easily several hundred volts. My guess would be maybe 500 volts with this, because it's a megometer. So 500 or 600 volts is not at all out of line, and 300 volts easily, like easily. And that dog will bite you. Like these will hurt. But we're gonna have some fun with this. This is really neat. I've never seen one with a transformer with multiple windings. You wanna see what we can get out of it? I think we're gonna have to come back to this in a future video, not long from now, after I've mounted my bench vise is the future. And we'll put this in a vise, and we'll put a meter on these and see what we get out of it, and see why we have 3 different windings and what we're getting out of those 3 windings. Because this is curious. It is entirely possible. Let's see if we can bring these close enough together right here, like that. I want to crank it enough to make a spark there, and I'm nervous that this, like, I might spark it to me. I'm gonna, see, I gotta clamp it down because I'm jiggling it all over the place, and I'm gonna move too much for you to be able to see it. I don't think it's going to need any kind of excitation. There's got to be a magnet in here. Let's check it for magnetism. Yep, there's a magnet. Not much though, not as much as I expected. It's a really weak magnet for its size and for what I expected. Like, that's probably an Alnico magnet. That's neat. So that's a 70s vintage little generator. We don't have a build date on this, but I gotta think it's similar to the rest of it. I love the gearing. So we've got a metal gear here, looks like bronze from the color, a plastic gear here, and then another gear in here that I can't tell if that's metal or plastic. And I don't want to take it apart enough to figure. I gotta think that's metal. And that takes us down into here, and I want to explore it. I'm gonna stop here because I don't want to fuck it up. But I want to explore this. I want to learn about it. You can see the thing moving down here. Can you see that inside there? Right here, you can see the drum moving, or the armature, technically. That's so cool. So this is much more advanced than the kind of generator you would see in like an old hand crank telephone. And it's cool that it's geared up so much, and it still requires very little effort to turn. But if I short these out and, you know, or put a load on here like a light bulb or something, this will get much, much more difficult to turn, because watts is watts, energy in, energy out. That's really neat. Well, that's a cool little autopsy. We're going to be back to this for a couple follow-up videos because I want to hook it up and zap it and see if I can make it arc. I want to measure the output, and I want to explore the inside. I want to look in there. I want to look in there really bad right now, but man, if I do that... All right, let's go. Let's just take a quick peek. Just a little peek. And watch me strip out the screws so I can't put it back together again. I got to break it loose with the big screwdriver because the little one doesn't have the stones. Let's just take a little peek inside. I just want to look. I just want to get a little look before we decide if we want to go in, you know, way deeper. Kind of like the belly button test. Okay, so we got a little oilite bushing in there, a little bronze bushing, and I'll bet I can slide this right. Oh yeah. I got to be careful though, because I got a little washer on the end there. This is, in case you're wondering, this is where I really fuck it up. Nope, we got out. There's definitely a magnetic field in there. Or is this the magnet? Because there's no windings in there. That's our magnet. That is absolutely our magnet. Okay, so what do we see looking at the magnet? We see there's a line drawn on it here in pencil, and there's a line across here. And if I had some of that nifty MagView film, I used to have a piece of that. I got to get another piece of that. I'll bet we would find that this is polarized in this direction, like north-south or north-south. It's going to be polarized perpendicular to its long axis. So I'm looking at just a magnet on a stick here, and I'm looking at this core, and I'm seeing it's cut in half, and we've got our two open spots, and this is probably all aluminum, either cast aluminum or some kind of cast really shitty pot metal. And I'm seeing this over here. This kind of feels like a backward shaded pole motor. You know? comment and tell me your thoughts, because I don't know what the hell, but this has that vibe, kind of like a shaded pull motor, but backwards. Like you can picture it. You can picture this creating eddy currents in here, and those going through this core. Like there's laminations here, and there's laminations here, and on the bottom. And I think that's how it works. All right, I'm gonna try putting it back together for now, but I want to explore this some more in the future. Can I get around the thing and back in the hole? Some guy did. Some 70s guy got that in there the first time. Can I get it back? I gotta get the gear. There we go. Okay, I got the gear to engage. All right, let's get the back on so we're safe. Get it all back together again. All right, we're in the bushing. Get our screws in. And line this one up. There we go. Now we're all preloaded and everything's good. Okay, and we'll tighten that down. All right. And it works. Everything turns just like it's supposed to. Cool. That's neat. And I'm glad I took that apart and got a little look inside. All right, guys. Thank you for joining me for this particular equipment autopsy of the little Biddle Megger, which is just cute and cool and neat and a fantastic exploration into 70s technology. I thought it was 80s. It's 70s. So for future reference, this is a Biddle instrument number 1946253, catalog number 21804. So now you know. From the James G. Biddle Company in Plymouth Meeting, Pennsylvania, made in England, as opposed to Plymouth, Pennsylvania. Huh. Thank you guys for hanging out. You are awesome. If you're interested in this kind of stuff, if you like what I do, I got a billion other videos on here. You should check them out. And if you look in the links below in the description, you can find that there's a Discord where you and all the other nerds in the world who will sit and watch a video like this are welcome to come hang out with other nerds, because you're not alone. There's a bunch of us who like taking things apart and seeing how the world works. And it's how we get smarter. We get to ask questions and get answers and learn things. And that's what this is all about, is just getting curious and learning stuff. You guys have fun. I'm Chris Boden. And as always, I'll see you next time.